All right, we're going to talk about exponential growth and decay, S10I. We're going to start off with the warm-up. So, is X an element of C? Notice X is not inside C, so the answer is false. Is X a subset of B? That is true, because X is inside B, isn't it? A union B is not equal to the null set. So let's say, is A union B equal to the null set? That would be false. But not equal, that would be true. Okay, A intersection B, that's this intersection here, is a subset of circle C. Well, that's clearly false. And then A intersection C is equal to the null set. That is true, because null set means that they're not overlapping at all. So that is true. So what is the important thing? So this sideways U thing means subset of, and the circle with the line through it means null set. I spelled that wrong. Null set. Okay, so you've got this example here you can read, but let's work on the examples we did during class. Okay, one of the things that we're going to need to change for every single problem is we're going to need to change the window, and we're going to be changing the x max and the y max. So let's do this first example together. Find the original affected value. So the original affected value is when n equals 0. So when n equals 0, I'm going to have 1.15 to the 0 power, and anything to the 0 power is 1. So the initial value is going to be 1,000, and what are the n is number of weeks, and a sub n is hectares. Okay, find the initial affected value after 5 weeks. So when n equals 5 and when n equals 10, let's plug it in. So here's my equation. So we type in 1,000 times 1.15 to the power of 5. Oops. And we get 2011 hectares. And for the other one, oops, we're going to change the power to 10. And we get 4,045. Let's call that 4,046 hectares. Okay, draw the graph of the affected area over time. Okay, so I'm going to press y equals and to draw our equations. Okay, so we press y equals, and let's type in the equation. 1,000 times 1.15 excuse me, to the power of x, and then we can graph that. Now, if you just hit graph, notice my x and y axis are a little bit messed up from the previous time I used the calculator. So once again, we're going to press window, and I'm going to change my x max to whatever I have on my grid. Let's call it 16. So changing the x max to 16. And my y max, if I look here, I've got 8,000. Let's just type in y max as 9,000. Okay. And now if I hit graph, it's going to you're going to be able to see a nice graph of this. Okay, so I changed the X max to 16 and the Y max to 9,000. Looking at this grid here. Okay, so if I want to draw this, it might be easier to get a table to get some values. So if I hit second graph, I can get a table, and so this n has to deal with time, so we're not going to have any negative time, and we already know the initial value was 1,000. Okay. Now after 2 years, it's 1,300, so that's like around there. After 4 years, we're at 1,749, so let's put it right about there. After 6 years, we're at 2,300, that's somewhere right there. After 8 years, it's 3,059, so that's somewhere around there. After 10 years, 4,045. 12 years, 5,300. So at first it looked like it was straight, but now you can see that it's curving up more because it is an exponential function. 14, we've got 7,000. Okay, that's about there. And at 16, 9,000. So it's like there. So it is an exponential curve, and because this is this a value, a is greater than 1, so that means it's growth. And you can see that it is growing as we move up. Okay. Now, use your graph or technology to find how long it'll take for the affected area to reach 8,000. So we want to figure out, when is this going to intersect 8,000? So when does it get right there? So on my calculator, I'm going to, when I hit y equals, on the next equation here, oh shoot, I didn't mean to do that. Okay, let's retype it. Times 1.15 to the power of x. Okay, and for the other equation, I'm going to type in 8,000. And then when I hit graph, you'll see the two equations are going to intersect. So here's the exponential curve, and there's the line at 8,000. So in all of these problems, we're going to figure out the intersection. So you're going to hit second trace, and then you're going to hit 5 for intersection. And then it says first curve. You should move the arrow pretty close to, I'm pressing the arrow and I'm moving it closer to the intersection. You can only use the left and right arrows, not the up and down. So we're going to arrow towards the intersection. And then I hit enter. And then it says second curve. We got 8,000. I hit enter. And then it says guess. I hit enter. And the answer is after 14.9 weeks, our affected area is 8,000 hectares. So for question D, after 14.9 weeks. Okay. So very important that you write down these calculator steps into your notes, because you're going to be using these steps for all of these problems on this page. Okay, so you may want to hit pause and write down these steps. Okay, let's do the next one together. Okay, so the increase of the length of ivy moves by this function, where x is the number of weeks. Find the initial value of the ivy. So the initial value of the ivy is the k value, because when x is 0, we're going to have this whole part is going to be 1. So the initial length is 2, and what are the units? Meters. And then for B, find the length after 10 weeks. Well, just like before, we're going to plug in 10 in for x, so 2 times 1.1 to the power of 10, and we get 5.18 748. So three significant figures would be 5.19 meters. And then C, how long will it take for the plant to reach 10 meters? So I'm going to type in my equations. The first equation is going to be 2 times 1.1 to the power of x. The second equation, I'm going to type in 10. Now we need to change our window, our x min and our x max. Our y min and our y max. So our y max, I'm going to set it to 30. So let's hit window. The y max, I'm going to set that to 30. And the x max, same thing, I'm going to set it to 30. And then if I press graph, we'll see our curve. Notice the A value is greater than 1, so it's growth. Okay, and so here's our graph. And just like before, I'm going to hit second trace, arrow over to the intersection, and then hit enter 3 times. So let's do that. Second trace, press 5 for intersection, enter. First curve, let's arrow a little closer to it. First curve, it says this equation, we hit enter. Second curve, it says y equals 10, I hit enter. Then it says guess, you hit enter, and then it tells me that the intersection is 16.88. So let's just call that 16.9 meters. Oh, wait, not meters. Find how long it will take, so it will be 16.9 weeks. Let's do our graph just so our notes are complete. So second graph. So at time 0 we were at 2. At 5 weeks we were at 3.2. At 10 weeks we were at 5.1 something. At 15 weeks we were at 8 point something. At 20 weeks we were at 13 something. 25 weeks we were at 21 something. At 30 weeks we were at 34 something. So off the charts. Okay. and we wanted to know when it was 10 meters. So we wanted to find this intersection at 10 meters. Okay. Okay, and for the next few ones, I'll do one more, and then for the next video, we'll just go over the answers for the next few and maybe talk about them. Okay, once again, this is very similar to the last one. Radioactive material has been spilled on the farmland, and we've got this um, equation where x is time in years and f of x is mass in grams. So x is time and y is grams. Okay, find the initial mass of the material. So the initial mass is 130 grams. Question B, find the mass after 4 hours. So let's type in our equation. So my equation is 130 times 0.85 to the power of x. Oh wait, not x, 4 years, right? I hit enter, and we get 67.9 grams. Question C, write down the horizontal equation of the asymptote. Now, let's think about it like this. Y equals k times a to the x power plus c. Notice there is no c value, so in this equation, c equals 0. So our horizontal asymptote is y equals 0 for the horizontal asymptote. Okay. Calculate how many years it takes before only half of the material to remain. So for half of the material to remain, we need to know what half of it is. So initially there's 130 right there. So half of 130 is 130 divided by 2 is going to give me 65. So we're going to draw a line here at 65. And we're going to try to calculate this. Y equals 65. So let's type in our equations. I'm going to hit y equals. And the equation is 130 times 0.85 to the power of x. And the other equation is going to be y equals 65. And we need to change our x max and y max. So I'm going to hit window. And our x max, I'm going to change to 30. And the y max, I'm going to change to 200. Okay? Alright, and so now I can graph it, and we'll see our graph. And notice it looks like decay. And that's because the a value is, our a value is less than 1. So a is less than 1, it's decay. Okay, so just like the other problems, we hit second trace, 5 for intersect. I hit enter, 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 and then it tells me my intersection is 4.265. So the intersection is going to be 4.27 years. Let's draw this graph. So, second graph to get a table. Okay, so we know at 0 it's at 130. At 5 we're at 57.68. 57.68. At 10 we're at 25.5. At 15 we're at 11. At 20 we're at 5. At 25 we're at 2. And you can see the pattern is decay. Okay, I hope this was helpful, and my next video will continue this, and we'll just go over the answers. All of them are pretty much the same as this. Hit pause if you want to rewatch this and check your work.